So today we will be discussing the topic green hydrogen or the hydrogen fuel cell, which comes under GS3 mains. Okay, it comes under the GS3 syllabus. So basically we will be looking onto it from the economic development perspective, the science and tech perspective, as well as the environment perspective. So basically we all are aware about. We can use our common sense to be know the facts regarding the science tech perspective as well as the environment perspective. But usually, actually, I am expecting the question of green hydrogen in an economic angle. So for that, to get that understanding, what I did is I analyzed the PYQs. So in 2018, a question was asked on the facts and fears associated with expanding nuclear energy in India. Okay, it's more of an economic development perspective question. Okay, and even though science and tech angles and environment angles can be added, the more of the question was on the basis of the economic development angle. And in 2022, the question was on whether we agree that India will achieve the 50% energy needs from renewable energy by 2030. That's the target we put forward. And to justify our answer, and we have shifted the subsidies from fossil fuels to renewable energies. So how will it's gonna be helpful for achieving that target? So such an angle, see, we have transitioned ourselves to renewable energy for environmental reasons using the technology, but the question came from the economic development angle. So we will be preparing this topic on green hydrogen or the hydrogen fuel cell, covering all these angles. And one more PYQ in the very recent year, that is this year's May. How can India achieve energy independence through clean tech by 2047? And the role of biotech in it. Okay, so it's more of an science and tech angle question, but obviously an economical angle is needed. So let's prepare our note on this, on the covering these all perspectives. Okay, so just as an introduction, we can actually change our introduction as per the question. So for the green hydrogen here, I am actually giving the explanation to it. What is green hydrogen? I am introducing yourself to this concept. It is the hydrogen, like the green hydrogen. Okay, it is the hydrogen produced through the electrolysis of water using renewable electricity sources like solar or wind power. So how hydrogen is produced is that we passes uh, electricity to water using a cathode and anode, and the water, which is H2O, splits to give hydrogen and oxygen atoms. Okay, that's how we produce hydrogen. Then how will it be green hydrogen? If the electricity that we passes, okay, comes from a renewable source like solar or wind energy, then it's a green hydrogen. But if the electricity comes from thermal power plants, then it is gray or brown hydrogen. Okay, so yeah, that's with the introduction part. So what are the needs? Okay, what make the world go for green hydrogen? What are the needs for it? Okay, the need here is, as per the global climate report 2024, 1.45 degrees Celsius temperature has been rise as compared with the pre-industrial levels, 1.45 degrees Celsius, and it is expected to rise by 3 degrees Celsius by the end of this century. 3 degrees Celsius by the end of this century. Why this is a concern? Okay, so we are aware about the global warming and things. So we have set a target to limit the global temperature, rise in global temperature under 2 degrees Celsius by 21st century. But as per the global climate report 2024, we are not going to achieve it, and more than that, we are going to exceed by 3 degrees Celsius. Okay, so that's a content. We are not able to like bind our agreements, bind our decision we took as per the Paris Agreement. Okay, then other concerns we usually read in newspapers, especially in the Delhi regions, that's the increasing heat waves. Okay, and the increasing power demand by India is another concern. Like the sources are limited, so but the increasing population and the change in lifestyles, and now AI has developed, which requires a lot of power for its use. So for all that, we need more power. We need to find more sources. Then another concern, the 71% power generation in India is from thermal power plants. That's a huge concern. The thermal power plants, we know they emit a lot of greenhouse gases due to the burning of coals and other gases. Okay. And another thing we can add is the reliance on fossil fuel based vehicles. Okay, that can be also added on this. So we need to transition to EVs or the hydrogen fuel cells which are currently developing. Yeah. So what are the advantages of using green hydrogen as main source of energy? It is a clean energy, as the word says. It's green. There is no greenhouse gas emission. Only water vapor and warm air is produced. Okay, only water vapor and warm air is produced. The warm air can be cooled. Okay, and the water vapor is not much concern. And another advantage is like the transition for EV is actually taking time, as there's a concern regarding the consumers that it is taking more time for charging. So in case of hydrogen fuel cells or the vehicles run under hydrogen fuel cells, there is no need for charging for hours. It can be done quickly. And the more another thing is that it's an efficient mode of transport. Like the efficiency of the engine is exceeding 60% efficiency compared to 20 to 40% in the internal combustion engines like the petrol or diesel engines. And moreover, it is a reliable power backup power. That is, uh, we can refuel instantly, and it's highly reliable and resilient. Okay, so what are the Indian initiative under this? What are have the Indian government taken as to promote green hydrogen? There are few initiatives. The one major one is the Green Hydrogen Initiative. Its aim is to develop green hydrogen production capacity of at least 5 million metric ton per annum. Okay, that's our target. Plus, additionally, it is trying to add renewable energy capacity of about 125 gigawatt in India by 2030. So this is the main aim of green hydrogen mission. We will looking more the green hydrogen mission later in the session. Okay, so just know that it's introduced by Ministry of New and Renewable Energy. Its main focus is to decarbonize the industrial or the transportation or the mobility and the energy sectors, and hereby reducing the dependence on fossil fuels. Then the another program site for domestic manufacturing of electrolyzers. We know we have already discussed anode and cathode electrolyzers are needed for uh, electrolyzing the water. So for that, for the production of green hydrogen, we need a lot of electrolyzers. Actually, we are currently importing all the electrolyzers. So the site program tries to make it in India, and hereby we can reduce the cost of production. R&D, so the research and development focuses on electrolyzers, obviously, and the hydrogen storage materials. So we need to store this hydrogen, right? So hydrogen being a very combustible and very light gas, it needs separate storing facilities. And like another Indian initiative is the Indian Railway has been experimenting with the hydrogen powered trains, which is a great initiative by the Indian Railway. And green hydrogen clusters have been developed as per under this program. Then what are the major issues in the production of green hydrogen? So we have discussed some of the things, like its cost of production is so high. uh, especially when compared to other fuels or even gray hydrogen. Uh, okay, so the cost of production is obviously very high. Why? The electrolyzers are needed, and cathode anode things are sometimes made of titanium for better efficiency, but these are very, sorry, it's made of platinum. So such metals are, we know they are so expensive. Then import dependency, like most of the electrolyzers are, uh, like we earlier said, are imported from other countries. So we are trying to make it in India through the site program. So it's a major concern, the import dependency. And for to make green hydrogen, we need the supply of renewable energy. Okay, so the renewable energy is actually costlier when compared to the fossil fuel energy. Okay, so that also led to the increased cost of production in the cost of production of the green hydrogen. Okay, then the weak private sector collaboration. Obviously, this need large scale of technology upgradation, high gestation period. So this all means it requires a high capital cost, a huge capital cost, which is not much attractive to the private sector as their business policies not go well with this. Then obviously there is lack of infrastructure, and the skill and the research and development gaps are also existing in our country regarding the same. So what are the major suggestions? So we have looked into the problems. We can actually like be able to guess some way forward. So prohibitive cost of production. So we must be able to reduce the cost of production. So how? Okay, we will look into it. So I am actually trying to make you guess some way forward from our from what issues we had written. So import dependency, how can we reduce it? We can manufacture in India. Large supply of renewable energy is needed. Okay, which increases the cost. So we can say more efficient means of renewable energy production, or we can depend on other forms of renewable energy production. We can look into it. So we weak private sector interest. So we should be giving some incentives to attract them, right? Right? Yeah. Lack of infrastructure. The policies of the government could address and develop the infrastructure. So skill and R&D gap. We can do the skill development programs and more funding on the R&D systems, right? So let's look into the suggestions. So like we have said, we can give incentives to attract the the customers to it as well, and for the producers. And we can bring down the cost of production by using low cost renewable generating plants. Okay, and we can replace platinum with nickel or cobalt, which are less expensive. Okay, production of hydrogen microbial electrolytic cells. Okay, we can actually there are other means of production of hydrogen other than uh, just electrolyzing water. Okay, so we can actually use or exploit such opportunities in front of us. So the production linked incentive scheme can be implemented for the electrolyzer manufacturing. We have seen what the PLI scheme had done in the mobile manufacturing sector in India. Okay, so such a revolution might take place in this electrolyzer segment as well. So we can say that. And the infrastructure development near ports and industrial clusters could be done, which will definitely, which with good infrastructure, the private players will definitely be attracted to it. And we can go for international collaborations, like partnership with European Union, Japan, or South Korea for the tech transport as well as the export markets. And there are some policy and regulatory frameworks we can put forward, like the safety standards, the green hydrogen certification, the carbon pricing, and all. Then for the financial mechanism, so this requires huge funding. This requires huge funding. So we can try to uh, so we can try to raise money through green bonds, concession loans, viability gap funding. So actually, the citizens are now more aware of it. They like to invest in uh, green initiatives. So green bond will be a great initiative. And we can also do skill development and awareness. So maybe we can quote the Skill India mission here, right? This evaluation. And we can go for phase development rather than forcing us with huge targets. We can actually subdivide our targets and aim for phase development of this project. So let's do a bit detailed about green hydrogen mission. So obviously the question is gonna ask about an analysis version of the green hydrogen mission. Even though we have discussed the green hydrogen in itself or the hydrogen fuel cell, the question might be asking to like analyze the green hydrogen mission and all. So it was launched by the Ministry of New and Renewable Energy in 2023 to make India a global power hub for production, usage, and export of green hydrogen and its derivatives. Please forgive me for the spelling mistakes here. What are the core components of it? As we have earlier discussed, 5 million metric ton per annum production of green hydrogen plus 125 gigawatt of renewable energy by 2030. We have to, it's better if we could by heart this aim. And another core objective of the scheme is the demand creation for attracting domestic use and for the export. Okay. And the site program, the strategic intervention for green hydrogen transition, and the pilot projects in emerging end use sectors. Okay, so the pilot projects have been, as like we have said, like the initiatives taken by Indian Railway and all. Developing of green hydrogen hubs and clusters obviously is an aim of the project. And the infrastructure support, the scheme, the mission is trying to provide infrastructure support for hydrogen storage, transport through pipelines and all. Pipelines. Oh, there's a lot of spelling mistake. Ports and export capabilities. Establishing robust policy guidelines, certification system, testing facilities are also aimed for the green hydrogen mission. And we don't have to by heart all these. So we could be able to remember the 5 million metric ton, 120 gigawatt, 2030. Okay, that. And the site mission that we had already quoted earlier, which we could be able to understand. From common sense, we can say this is actually a new sector. There is very less demand for it. So we can say it's trying to attract some demand for it, to create some demand. Then it's a new project. So we would be doing some pilot projects, right? So from common sense, we can add such topics. And yeah, developing of green hydrogen hubs, then the infrastructure support, and robust policy guidelines, new sector. So we need strict policy guidelines and certification system and testing facilities for safety. Yeah, then there's a SHIP program for the R&D development, research and development, and thereby fostering public-private collaborations. Okay, so from the common sense itself, so see, how can we, when we look at the core components of green hydrogen mission, we might think it's a lot factual. Actually, it's not that factual. We may be able to, we can say the 5 million metric ton, 125 gigawatt, it's a factual data. But the things that are coming down, it's not that factual. Okay, so from common sense, it's a new sector. So the government have to create the need for it, create the demand for it. So demand creation is one such thing. It's a new project. So government must be trying some testing or like testing projects. The pilot projects have been done and they need to expand it, right? So some development of green hydrogen clusters of hubs. Then for developing this, we need infrastructure support. That's also provided through this mission. And that's a new thing. So there should be some policy guidelines or certification, otherwise a lot of corruption and other things, quality standards might violate. So such things are also happening. Then another two factual things that comes is the site program and the SHIP program. Okay, SHIP program is for the R&D Side program is for like it's for the electrolyzer development. Okay, so actually the 3 points here are factual. The 6 other points are from just common sense. So learn one factual point and score the marks with the common sense. So the challenges, the way forward, and everything goes the same with what we have learned in the green hydrogen. Okay, the green hydrogen regarding the back hydrogen fuel cell. So it will go the same for the green hydrogen mission as well. And as conclusion, we should be able to write a futuristic balanced conclusion. The green hydrogen mission can secure India's energy future and global leadership in decarbonization, but its success hinges on reducing cost, building infrastructure, ensuring safety, and advancing R&D through a phased and collaborative approach. Actually, it's a bit lengthy. We can shorten it. Okay, uh, the green hydrogen mission will get successful. We can write like that. It will get successful by reducing cost, building infrastructure, ensuring safety, and all. Yeah. I hope today's sessions was fun. I hope you guys will prepare this note, and the more important thing is this note covers the entire aspect of it that we needed for a mains answer, and the note is prepared in a mains perspective, a mains answer perspective note. So I hope it was a useful section to you. Thank you and have a great day.